All right, thank you. So, in the last lecture we were discussing this linear time algorithm for finding medians, right. So, the key basically is the fact that whenever you can divide it into two sub problems, there is a sum of the two sub problems. In this case we look at n over 5 and 7 n over 10. This n over 5 is 2 n over 10 plus, so that gives you 9 n over 10. Effectively what you are saying is I am able to reduce the problem from size from n to n over 9 n over 10 with only spending a linear amount of time. That is the reason we are able to show that this algorithm is actually going to be linear time. In the other case, when we chose n equal to 3, k equal to 3, that did not work out because the sum of the two problems was exactly equal to n, and that basically became essentially a n log n algorithm. Now, remember in practice, this 7 n over 10 is the worst case time, right? Because we are guaranteed 3 n over 10 to be removed. In most cases, this constant is not going to be 9 n over 10. Most likely this is going to be somewhere like a 6 n over 10 or something like that, right? Okay, or if you get lucky, because we don't know which side we are going to go. So most of the time in practice, this algorithm is actually going to be the depth of the recursion is going to be a lot less than what this is telling you, right? But and the other good part about this is that it's guaranteed to be linear in the worst case. All right? Yeah.
After you remove one side of the thing, what algorithm do you use to find the kth element of the remaining?
You just call the same algorithm recursively. So that's where the beauty of recursion is, right? So whatever algorithm you applied, so you have n equal to 1000, right? So you'll solve two sub problems of size. One will be of size 200, the other will be of size 700. Both of them will call the same algorithm again, but now with smaller problem sizes and different values of k. One case you'll find the 100 value in the 200. In the other case, you'll find whatever the appropriate k is for the remaining 700. All right? Any other doubts? All right. So what we're going to do now is we have so we have now we're going to look at another problem, right, which is finding the pair of points with the shortest distance. All right. So let's say that I give you I have a list of points in 2D. These are my points. For now, let's assume that all the x and the y values are unique. That means you don't have two points which are exactly the same, or even with the same x value and y value for now, right? Although that's not a requirement for what we are going to discuss, right? Now, if I look at this list right here, right, okay, visually you can figure out very quickly that maybe the two closest points are these two or these two, something like that, right? These points are in a two-dimensional space, right? But a simple algorithm to find the shortest pair of points will be what? You have n points, right? So you do for I equal to 1 to n, right? What you do is for I equal to 1 to n, for j equal to I plus 1 to n, right? Compute dij, and if dij is less than best so far, then best becomes equal to Dij. And computing the Dij is nothing but finding the Euclidean distance, which is nothing but square root of x1 minus x2, or sorry, x1 minus x2 whole xi minus xj, and plus yi minus yj whole square, right? Okay. So, for example, if I need to compute the distance between these two, I just take the difference in the x values and the y values, take the square of the x values, square of the y values, take the square root of them. You can ignore the square root step because whatever is the smallest distance will also have the smallest square distance, right. So, you can just compare, instead of computing the distances, you can just compute the square of the distances, and that should also work fine. But how much time does this algorithm take? This will take n square time. And our goal is to try to see if I can reduce the time from n square to something lower than n square, right. Okay. So, let us say that what I do is I play the same trick which I have been playing so far. I divide this list into say roughly two equal parts along the x axis, or I can choose the y axis, it does not really matter. All right. And I say, okay, fine, you know what, my algorithm is very simple. My algorithm is very simple, that I will find the shortest pair of points on the left side, okay, recursively, right. I will find the shortest pair of points on the right side also recursively. So, for example, the shortest pair of points on this side may be this, the shortest pair of points on this side may be, for whatever reason, this, all right. And then I say, well, you know what, I take the minimum of the two. Will that work? Why will that not work? There will be solutions which go from this side to that side and that side to this side. So, for example, you may have a set of points here and here, right, where essentially the distance between these two is lower than everything else. So, let us analyze this recursive algorithm. This recursive algorithm will basically say, I have a problem of size n, I solve two sub problems of size n over 2, take the minimum, but that does not work. So, now what I need to do is I need to look at all the points, all the distances from all the points on this side to all the points on the other side, right. How much time will that take? There will be the n over 2 on this side, n over 2 on the other side. What will happen is I will essentially spend plus n square over 4 amount of time to go from here to here, from this to this, from this to this, and so on and so forth. Correct? Now, you know what? What will happen in this case? I apply my Master's theorem. What do I get? N to the power log 2 to the base 2, which is nothing but order of n, and this is nothing but n square over 4. So, this is the case in which the top part decides the overall time, because the f of n is taking more time than the n to the power log a to the base b. So, f n is nothing but n to the power log a to the base b plus 1, which is epsilon in this case is nothing but 1. So, if you solve this, you will get T n equal to order of n square. Not a lot of saving, because I started with n square, I got to n square. All right. Now, if you look at this carefully, you say, hey, maybe I'm really wasting my time doing a lot of stuff, right? So, if I look at this set of points which I have here, let us say that this shortest distance is delta 1, right, okay, and this shortest distance is delta 2. Okay? All right? Now, I take the minimum of these two values. So, delta is nothing but equal to minimum of delta 1 comma delta 2. Okay? So, what do we have here? We have delta 1. I suppose I draw a line here. This is delta 1. This is delta 2. Sorry, I make the line to be both deltas. Okay? Now, remember one important part, right? The important part is that if I already found delta 1 and I already found delta 2 and delta is the minimum of these two, I am only interested in now finding pairs of points which have a smaller distance than this delta, right. So, suppose delta 1 is equal to 4 and delta 2 was equal to 3, then I say, look, I do not care about points, I do not want to look at pairs of points which are going to be further than 3, because that is just a waste of time. My goal is to find the pair of points with the smallest distance. You had a question? No. Okay, all right. All right? Okay? So, what I will do is, whatever this line was, right, and remember I am skipping a lot of details right now, because how do I find this line? I have not told you how to find this line. Just basically, it is nothing but I take all the elements and I sort them based on the x value, right. Okay, I sort them based on the x value, or I just find the median, one of the two. If I sort them, it takes me n log n time. If I find the median, it takes me n amount of time, right? Right? Because we already did the median, we just saw the selection problem which is guaranteed to find the median in n amount of time. So, so now what I do is, I look at the two borders. Now, what is guaranteed is that the shortest distance cannot be, none of these points can contribute now to the shortest distance. Correct? None of these points can contribute to the shortest distance, right? Because essentially, if I look at any of these points here, if the shortest distance was to this point, I already covered that. If I look at a distance between this point and this point, along the x axis itself, the distance is going to be at least delta, y axis will contribute a little bit more to it. So, the distance cannot be smaller than delta. So, that means I cannot have a point here x and a point here y such that the distance is less than delta. Similarly, I cannot have another point y here and some x on this side. This is my median, right? This is my median line, right? Okay? I cannot have those points. So, the only pair of points which are relevant at this juncture is something which is lying in this border from here to here. All the other points I can just throw away. They are not going to contribute to my problem. So, that means instead of doing this pairwise point of every point from this half to every point in this half, I can now restrict my problem to all the points which are on the say all the points here which are say R1, no, let me not use R, M1 and M2 on this, which I just need to do M1 cross M2 and I should be done. So, now what is the time? Time taken is nothing but Tn equal to 2 Tn over 2 plus M1 times M2. With me so far? If this is M1 times M2, I have a problem though, right? What happens in the worst case? Say, let's say that even 10% of the points are in this border and 10% of the points are in this border, right? It's possible, right? How much do I get this to be? This becomes 1 over 100 times n square. Even at the top level, I already spent 1 over 100 times n square time. What happens at the bottom levels don't count anymore. So, overall algorithm is still going to be order of n square, although with a much better constant, right. So, although I was able to prune all this stuff on this side, all this stuff on this side, even if a small fraction of the points which is constant fraction of the times on this and this, I get into trouble, correct. So, just pruning stuff out does not seem to help me here. It just reduces my constant, but really does not help me a lot. Okay. So, what I am going to do now is the following. I will say, okay, let me get smarter. I will take all these points here and I will sort them based on the y axis. All right. Okay. I will take all these points here and I will sort them also based on the y axis. All right. Now, what I will do is I will start from the top point here. Let us say that this is the top point here. Okay. All right. So, remember these points are now sorted like this. These points are also sorted like this. Okay. Now, remember what is my goal? My goal is to only look for pairs of points which are less, which have a distance, which has a chance of me finding a better, shorter pair than delta, right. For that I can say, look, if I look at a box which is of size delta along this direction and 2 delta, these are this is the only box where I can, for this particular point, I can find a point which is less than delta, because if I go outside that box along the y axis, this point is always going to be larger than distance delta from this point, because along the y itself is delta. Similarly, so that means the only chance I have of finding this point in this box is, that's the only relevant space I need to look at for that particular point. Then what will happen is, once I am done with this point, the next point may be here. I will again draw a box like this, again look for points within that box, right. And I keep doing that scan, go down the whole list. All right. So, the challenge is, how do I figure out how many points can there be in this box? Now, it is possible I get unlucky, all the points are in that box, right. All n of them can be in that box, right, or whatever I am not able to prune, all of them are in that box. Then it will take me a lot of time. But the thing is, remember, let's expand on this box a little bit, right. Let's look at this box in a little bit bigger, right. This is delta, this is delta, this is delta, this is delta, this is delta. Excuse me, sorry. All right, this is delta, right. Okay. Now, remember, what was the property which we had? Any 2 points on this side here cannot be remember we found what is the value of delta? Delta was minimum of delta 1 and delta 2. That means that essentially if I look at any point here, so along the y axis, let us say that I was looking at this point and this is one of the candidate points, for example. Then essentially I have to look at a box of size delta times 2 delta, right, with a guarantee that no pair of points in this group has a distance less than delta. How many points can I fit in that such that the distance is less than delta? Very small number of points, because suppose I want to put one point here, this distance may be this distance may be larger than delta, right? I can maybe put another point here, maybe another point here. You can essentially prove that the maximum number of points you can fit in that box is 7 or 8, even if you try hard. So that means what you're saying is that I don't need to compare with all the points. There only can be a small constant number of points that I need to compare with. So what happens here? You start scanning here, and then you say, okay, I'll collect. Remember, I don't need to compare against this side at all, because this side is already covered in the divide part, right? I only need to look at points which lie in this box of size, delta by delta, and those points can maximum be 3 or 4 of them. All right? Because remember, I can't pack one property. If I put too many points here, for example, it'll break the property that the distance between these 2 points is at least delta. The number of points I can put in this box is very small. It's generally, I can show it geometrically to be less than 4, for example, right? Maybe I put 4 I can put 1 at all of these corners, and then maybe I'll be guaranteed that the distance is at most, or at least delta, right? So all I do is, I sort this list, I sort this list. So now remember, when I sort this list and I sort this list of points are in the ascending order of, or increasing order of y or decreasing order of y, doesn't really matter, right? For this point, I will only, so think of it this list, I have 2 sets of pointers, one starts here, one starts here, right? Okay? So all I do is, I take this point, compare with all these points. The number of these points are guaranteed to be less than 4, all right? Then I move to the next one in the list. This point will move maybe to the next one here. This point will move to the next one here. Again, I take this and I compare with all of these. Then this one moves to the next one here. This point moves here, and this point moves to the next. So there are 2 pointers which are sweeping the right list. All I'm doing is, the first pointer is here, second pointer here. Every time this moves down, this moves down. How much it moves down depends on the data.
It's because your lambda window is moving down.
Exactly. So the window is moving down. So that the top part of the window is always going this way. The bottom part of the window is also going down this way. So in the worst case, what will happen is, essentially, even if you have n points here, this sweep will only take n amount of time, because every time the top pointer and the bottom pointer are moving, but by some amount, the maximum they can move over all of the possible data is only n. So if I sum up the work for all of the comparisons, it's only going to be n. Further, every comparison only takes, the number of elements in a window at any given time can only be 4. So the amount of comparison which I need to do is only 4. So now what has happened is, instead of this time being m1 times m2, this time is going to be nothing but some c times n, which is, I start here, compare with this window, move this guy down, move this guy. The movement takes n amount of time for each of the 2 pointers. The left pointer also takes n amount of time. Every time I compare, I only compare with 4 or so points. That takes n amount of time. But I skip some of the time, right? I have to sort this list based on the y values on the either side, because they were not sorted, right? So that time is some d n log n in the worst case, right? Because remember, the number of points here can be order of n on this side and order of n on this side. It's just that what we have shown is that if I do this sorting, I can just do one sweep and I can get done, and the sweep only takes me order of n time. Okay? So now what happens is, the total time Tn is nothing but 2Tn over 2. We'll obviously ignore the smaller one and call this as En log n. Now if you apply, you can't apply the master's theorem to this. This is one of those odd cases where it's not, remember, it only works for if I look at this is n log of 2 to the base 2. This gives you n, but this is n log n, and n log n is not n to the power 1 plus epsilon. All right? It is actually somewhere between n and n plus 1 over epsilon, because log n is always less than n to the power epsilon. So, we can't apply Master's theorem directly. So, what we will do is we will basically start opening this up. So, the top level time is n log n, right. The next level time will be what? N over 2 log of n over 2 times 2, okay, because there will be 2 sub problems of sizes. The next level will be 4 n over 4 log of n over 4. If you count that time becomes nothing but n log n plus 2 n over 2 log of n over 2 plus 4 n over 4 log of n over 4. So, this gives you nothing but n log n, and this cancels out. Log of n over 2 is what? Log of n minus 1, right. The next one is nothing but log of n minus 2, and so on. So, this is basically become now a arithmetic series. Log n is the first term, log of n minus 1 is next term, log of n minus 2. This is, remember, this is not log of n minus 2, this is log of n minus 2, because log of n over 4 is nothing but log n minus log of 4, which is base 2. So, nothing but n minus 2. So, if you sum this up, what you will see is that this comes out to be nothing but n log square n. Okay. So, what we are able to do is we are able to reduce the time from n log. Now, remember we forgot to count the time. Remember, we didn't. I said that this line is nothing but finding the median along the x axis. So, that roughly half the points are on this side, half the points are on this side. So, you can actually add another f of n time to actually find the median here, but that won't change the analysis. All that will do is increase my constants. Okay. Any doubts, questions on this before I proceed to a slightly better algorithm than this? Anyone? All right. So, now what we are going to do is we are going to try to say, hey, how do I, what is the problem creator? The problem creator is essentially doing this sorting along the y axis, right? Okay. All right. The problem creator is actually sorting along the y axis, because that's what is eating up most of my time. And other problem creator somewhat is finding the median, because I need to compute the median every time, right? Okay. So, what I am going to do is the following. I am going to change the problem a little bit. I want to change the problem to the following. Suppose I have a pair of points 2, 5. So, this is my x, which is 2, 5, 3, 7, 1, 2, 4, 3, 3, 4, 1, 6, 2, 8. This is my x coordinate, this is my y coordinate. All right. So, I say that I will give you a sorted. I will sort both these lists along the x axis and the y axis. So, remember, these points are 1, 2, 3, 4, 5, 6, 7. And let's say we add another one just for sake of clarity. Suppose I add 4, 1, or whatever, right? Okay. So now what happens is, suppose I have a sorted list which is nothing but I have a sorted list, I have an index x sorted, which tells me the index of all the points, right? In this case, what is the sorted list for x? X is nothing but the smallest point is 3, 6, then 1, then 7, then 2, 5, 3, and 8. Right? That means these points are, if I put them in this order, all these are points. This is point number 1, 2, 3 up to 8. If I put them in this order, they are sorted based on x. And now I also give you a ys, which is a sorted index based on y. So in this case, what will happen? 8 will come first, then 3, then 4, then 1, right? Then 6, right? Okay, so I made a mistake. 8, then 3, then 4, then 5, 1, 6, right? And then 2 and 7, right? Okay? Correct? All right? Okay? Now suppose I need to divide this list based on x median, right? Okay? What will I do? I will essentially, in this case, to find a median is very simple. Median is nothing but the second point or the 7th point, depending on how you want to do it, right? Suppose I use the second point as my median. So what will happen is, in that case, all these points 3, 6, 1, 7 are going to be on this side, and 2, 5, 3, 8 are going to be on the other side. So all I need to do is xs gets copied as it is. I get I get essentially 3, 6, 1, 7, and so basically I can just pull out all the values of x which correspond to 3, 6, 1, 7. They will be on this side, and they will be on that will be on the other side. Now when I'm pulling these 3, 6, 1, 7 out, if you look at 3, 6, 1, 7 out, what happens here? This is all the points are 3, 6, 1, 7 on this side, and I have 2, 5, 3, 8 on the other side. Right? Okay? What happens now? This is nothing but, if I look at 3, 6, 1, 7, point number 3 is nothing but what points I have? 1, 2, right? 6 is 1, 6, 1 is 2, 5, and then 7 is 2, 8. These are the points which I got on this side. Okay? If I do it this way, what happens is these numbers are already sorted based on the x axis. But what I really want is them to be sorted based on the y axis, because remember I have to do the scan of y on both the sides. So what will be the y? So this the sorted list of xs will be nothing but essentially this point, this point, this point, this point, and sorted list of y will be nothing but I'm picking up 3, 6, 1, 7. If I pick up 3, 6, 1, 7 in the same order, right? Basically the ys will be nothing but 3, 1, 6, 7. That means in this case what will happen is xs will be nothing but what am I choosing xs to be? I choose XS to be 3617. So I'll choose XS will be nothing but I need to choose 3617. So 6 comes first. So I'll get 617 and then 3. And the points chosen will be nothing but I'll get all the points which are less than the median, which were point number median was median which was chosen was nothing. So this was my demarcation point here, right? So the points chosen are 6, 1, 7, 3, 3, 1, 6, 7. So I will essentially choose. Hold on. So I'll follow the same order. 6, 1, 7, 3. So 1 is the first one. I have 2, 5. Then 3, point number 3, which is 1, 2, and then third one is 6, 1, 6, and then the 7, 1, 2, 8. All right. So these are points. These are points basically, which is are nothing but what was the first point here? 2, 5, 1, 6. I'm sorry. 1, 3, 6, 7. And so the ordering now again is the same 6, 1, 7, 3. Did I get it correct? Hold on, I made a mistake someplace. Just give me a minute here. All right, so what I have here is I had my list X and Y, right? This was sorted based on X, this was sorted based on Y. All I did was I found the median, which was essentially, hold on, that's probably what the error is. So the median was 7 and 2, right? So all the points which were just less than 7 came on this side, okay? So those are 2. So I have all the points which are less than this value, which is corresponding to 7. So all the points which are less than 2 coming on this side. So those are nothing but 1, 3, 6, and 7. That's correct. Okay. All right. And so all I need to do here is I have XS and YS. So these are the points which got there. So what I'll do is I'll select these points back in the same order of X and the same order of Y. So what will happen is my XS will be nothing but corresponding to 1, right? So I chose 1, 3, 6, 7. So I will end up with here 1 XS will be nothing but 3. All right. And then, so this is 3, XS is 3, 6, 1, 7, right? And YS will be, sorry about that. So this is basically just copying this as it is. And the YS will be 3, 1, 6, 7, right? Okay. And so what happened now is that what I was trying to show here, and I can do the same thing with the right hand side. What this is basically saying is the following, that if I gave you a set of points and I sorted them based on X and Y and provided you as 2 sets of pointers, you find a divider, I get essentially 2 sub-problems which are identical to these 2 sub-problems. What's the advantage of doing this? The advantage of doing this is now I don't need to sort these points anymore because these are already sorted for me along the y-axis. Similarly, the right-hand side, I'll have it sorted along x and y-axis again. So now what happens is my Tn. So if I already gave you this to be sorted, then I get 2 sorted sublists both along the x and the y directions. So now my time complexity is how much? Remember my time was T2n. First, I needed to find the median. Finding the median for any of these sub-problems will take how much time? Median is very simple. You just pick up as I picked up here, the median is nothing but picking up either this element or picking up this element. which is nothing but looking at the x index, finding the middle one, and that's your median. That divides the list into two sets of points. One set of points which are on this side, one set of points which are on this side. The other thing that we needed to do was we needed to sort along the y-axis like this, or you could start going from here and go up like this. It's not going to make a difference in our algorithm, because all we do is start, instead of scanning from the top, I can scan from the bottom. Or if I want to scan from the top, I move from the right and move towards the left. The important part for doing this scanning was I needed to sort along the y-axis. But now what has happened is, because of this decomposition, I already have a sorted list along the y-axis of all these points 1, 3, 6, 7. I'll also have a sorted list of points on the other side. How much time does it take to decompose this? Decomposing this is very simple. XS I can just get by copying this part. Similarly, for the right hand side, I'll copy this part. For YS, all I do is scan the list in the same order. Whenever I get a 3, I pick up those values and put them in. That will take me order of n time. So what the claim is that I can start from here, decompose this into in order of n time. And for each of those two problems, I have y lists which are already sorted. So now what has happened is Tn has now become 2Tn over 2 plus time to decompose, which say is d times n, plus the time, let's call that as c times n, plus time to then do the scan. Now the scanning only took me n amount of time. The main time was the sorting time. So I've been able to reduce the sorting time to now. The sorting time is already given to me because the lists are already sorted. So I just have to add dn. Yeah, I'll come to that in a minute. So if you give me all these things that is sorted at the top level, then the lower levels now are automatically sorted for me, because I'll only pick and choose the sorted part. And so what has happened now is that Tn has now become equal to order 2Tn over 2 plus some f of n. If I solve that, Tn has become order of n log n. Okay? So what's the trick going on here, right? What we are basically saying is the following, that suppose I have my input problem. First, I have my input problem as A. I first convert this into an input problem of type B. Okay? The type B problem has, the only difference is it has the same set of points, but I sort based on x and y given to you. What's the advantage of that? The advantage of that is that at this juncture, if things were sorted, I have a quick way of finding the sorting part for the left and the right, which only takes me order of n time. So the amount of work at every level now is only n. So the total time is n log n. But if my original problem did not give me this list xs and ys, what will happen? I'll have to actually go from A to B. How much time will that take? That will take n log n time. So because I'll have to sort based on x, and I'll spend the 2n log n time first solve this problem B. And now solving B becomes only n log n time. So what's the overall time? Is n log n plus n log n, which is 2n log n, or E n log n plus f n log n if you want to put the constants in there. And so your overall time is only order of n log n. What was the trick? The trick basically is very simple. The trick here which we apply is the fact that before what we were doing was the following. We were taking this list, dividing this into two parts, and sorting here, and sorting here, and then dividing this into two parts, sorting here, sorting here, sorting here, and sorting here. And the sorting was actually being done at every level, which basically made the time to be n log n at every level roughly, and here log n level, so it required you n log square n time. rather than doing this, what we have now done is we say, well, you know what, I don't want to spend sorting time at every level. Let me take the original problem, first sort it. So this is already sorted. Okay? So I'm going to spend the time to convert from this problem A to this problem B, and I'll spend the time of doing the sorting. But once I sort it once, then I can decompose these into two subproblems such that I already am taking a sorted list and kind of dividing it into two sorted lists automatically, and such that this time taken is only Cn. So I already get kind of sorted list here without actually paying the price of sorting, because that time is already spent there. So rather than sorting at every level, now I'm only sorting at the top level, and effectively now my time taken is gone down from n log square n to n log n. Now this is a little complicated, right? Okay. So the key thing to remember here is that if I have this two sorted lists both along the x and the y axis, all I need to do is to divide up xs into two parts. Xs copies here as it is for the left side and the right side, because x is already sorted based on that. For y, all I'll do is whatever points I pick up, I go look at those points in the same order as x, and then just pick those points, and that becomes my ys. So that is the part which you need to go back and carefully think about, right? Once you get that, all you're saying is, hey, if I have two sorted lists for the entire set of points, I can find the sorted list along x and y for the left side and the right side in order of n time. And if I have the sorted list already, then when I'm scanning, which I had described earlier, that scanning is going to be easy because things are already sorted along the y axis. Okay? And so the overall time taken is nothing but n log n. I'll take a break right here. If you have any questions, I can answer before we disperse. Yeah.
Yes, I guess the problem we did in the first half.
Uh-huh.
At the end of that selection that we did, do we get the midpoint of the problem or the k smallest element?
We can talk that afterwards. If you have any questions on this one, I can answer it, because that one we can discuss it one-on-one. All right. So what did we achieve? We first started with the n square algorithm, right? And then we say, okay, let's start pruning everything outside this border and this border. But that really didn't really help us much, because only it could still be n square with a much smaller constant. Then we said, okay, fine. You know what? If I do the scanning will guarantee that I will only require n amount of time. The problem with that, unfortunately, was we had to sort along the y for both the sub-halves. Unfortunately, when you do recursion, that problem will be applied to all the lower levels also. Then we said, okay, fine. If I give you a sorted list for xs and ys at the top level, I can then break it up into sub-problems where I can derive the sorted list for this and this, because easy to do. All I need to do is scan this list in the same order as what I was looking for x, and I'll get the two sorted lists. So now I need to do sorting only at the top level, and I don't need to do sorting at every level. All right, see you on. Oh, a couple of announcements. So you will get an assignment tomorrow, which on divide and conquer, which will be due exactly in 1 week. So that means, what is the date tomorrow? Let me just make sure. Tomorrow is the 28th. So what will happen is that, let's see. Just let me look at the dates here, okay? All right, so this will be due on the, you'll have it 27th, so it will be due on the 3rd, all right? No, is that correct? You'll get it on the 28th, it will be due on the 4th, right? It will be due on the 4th, and then the first exam will be on February 10th. So your midterm will be on February 10th, and it will cover only divide and conquer, up to divide and conquer. So whatever I teach is starting next lecture, will not be covered in the first exam. All right? Is that clear? So the assignment is due, it will be given out to you tomorrow, it will be due a week from tomorrow, and the exam will be on February 10th, which is a Tuesday, right? I'm sorry? You can do either. You can do a hard copy. I'll just double check with the TAs if they can accept hard copies, but if they cannot, all you need to do is take your hard copy and scan it and PDF it, right? One of the two.
So the exam will only include divide and conquer?
Exam will cover everything I have covered up to divide and conquer, right? Okay, it won't cover anything which I cover starting the next lecture.
What's your office hour?
Oh, they didn't put it on the web as yet? Okay, I'll make sure that you get it by Sakai, all right? Okay?